There's a new channel called Psyche Depth that was created just 4 months ago. In that short time, it has uploaded 153 videos, gained over 88,000 subscribers, and pulled in more than 5.8 million views. Here's the shocking part. Those 5.8 million views could generate around $30,000 in ad revenue. And this creator did it all in 4 months, using faceless videos created with AI. Now you're probably asking yourself, how did this channel grow so fast? And how can you do the same? I know how they did it because I also run faceless channels. Today, I'm going to show you step by step how to automate the entire process with a simple click of execute. This automation will write the scripts, generate the voiceovers, create the videos, and finally stitch them together to match the editing style of Psyche Depth using a tool called N8N. I'll walk you through the exact process I use to build these automations that have helped me create successful faceless channels. Before I start working on a faceless channel, I like to study similar channels to see what's already working in that niche. I go to the channel and look at its videos, but I don't start with the latest uploads. I sort them by the oldest videos so I can see what didn't work before the channel blew up. If we click on the oldest uploads, we see they're all from 4 months ago with modest views, 1,000, 700, 800, 900, and even 500. These weren't successful, but as I look deeper, I notice some videos start to pop. For example, one uploaded 3 months ago has about 95,000 views. As I keep scrolling, I start seeing others with 7,000, 30,000, and 70,000 views. Looking closer, I notice a pattern. Videos with women in the title tend to perform better than the ones that don't. The people behind this channel saw the same thing. That's why they started uploading more videos on that topic. As a result, their channel blew up, jumping from 6,000 views to 130,000 and beyond. This proves the most important part of starting a faceless channel, understanding what your audience wants. Next, we need to brainstorm video ideas. To do this, I copy the channel link and go to ChatGPT. I use this prompt. Analyze the titles and view counts of this channel and create 10 videos ideas for my channel that are likely to perform well. This way, ChatGPT analyzes the data, identifies what works, and generates 10 fresh video ideas that are proven to attract viewers, giving us a strong starting point. Now, let's copy and paste these titles into a Google Sheet. This will serve as our content database where we're going to store all the assets, voiceovers, images, videos, and system prompts. You can get access to this Google Sheet in my community by simply clicking the link in the description, then head over to the classroom where you can access all my blueprints. Next, we're going to automate script writing, video creation, and video editing using a tool called N8N. N8N is a workflow automation platform that lets you connect different apps and set up AI-powered workflows without writing a single line of code. Now, there are 3 main ways to host it. The first option is to host N8N locally on your own computer. This option is free, but it is more complex to set up. The second option is using Hostinger for hosting N8N. This is the easiest, quickest, and lowest cost way to host N8N. This costs just $5 per month. It's easy to use with 0 setup required. You also get unlimited workflow executions and unlimited active workflows. The third option is the N8N Cloud, which is the official platform by N8N. This costs £24 per month, which is approximately $30. This option is much more expensive, and the features are limited too. In this video, we are going to purchase 8N from Hostinger, where we get unlimited workflow executions and unlimited active workflows. So to host N8N on Hostinger, just click the link in the description, and it will take you to this page. Select how long you want the hosting for. If you choose 24 months, you'll get the best price. Make sure to use my link to get a 20% discount code, which reduces the price to $3.99 per month. Now scroll down and click on the application. Then select N8N from the list and click Continue. Fill in your details, enter your payment information, and click Checkout. Now that we've successfully set up N8N hosting, you can access the template for this workflow in our community inside the classroom. Scroll down and download the templates. Then go to N8N, create a new workflow, click Import from File, and upload the blueprint file you just downloaded from the community. I'm going to walk you through how I built this workflow step by step. As you can see, this workflow is broken down into 6 to 7 steps. I'm going to execute each step first, and then I'll go into each node in the workflow to explain how it works and how it was set up, so that you can have a better understanding of how to build this yourself. Okay, first, let's execute step 1. Create story, image, and video prompts. As you can see, the story was saved in the story column. If we move over to the production sheet, our AI agent has generated 14 image prompts, 14 voiceovers, and 14 video prompts, 1 for each scene. And if you look, we also have the image link column, the voiceover link column, and the video link column. Later, these columns will be populated with image, voiceover, and video links as we execute more nodes in this workflow. Now, the most important question is, how did we generate these prompts? If we start with our input section over here, you'll see I'm using a manual trigger, but this works best with a scheduled trigger, which you can set here to run once every day. However, for the purpose of this video, we're going to continue using a manual trigger. Next, we have this Google Sheet node. The purpose of this node is to get our video ideas from the Google Sheet, the same sheet where we added the titles earlier. In the first few columns, we have manual inputs: the title, voice_ID, which I'll explain later, aspect ratio, and the production status. Finally, we have the completed video column, which will be automatically populated with the finished video later on. If we go back to our Google Sheet node, you'll see that the only filter we have here is status, which checks whether the status column has in production. You'll see later in this video that when the automation is complete, it will be marked as done. So this row will be auto-skipped the next time the automation runs. Now, if we go back to the Google Sheet and focus on the voice_ID, this is the voice we're going to use for the video. This system will be using 11 Labs, which is one of the best text-to-speech platforms. You can create your account for free, then go to the Voices page and pick the one you like. I've already chosen mine. Just click the 3 dots next to your chosen voice. Copy the voice ID, and then go back to the sheet to paste it under the voice_ID column. Once we've pasted the voice_ID, we can apply it to all the titles. As you can see, once those required columns are filled out, the information pulled from the sheet into the Get Idea node is pre-populated with the details, including our voice_ID. We're then going to pass all of that info into the Story AI agent. Now, if you look at the user prompt here, we are only passing the title, but we also need a robust system message. Now, looking at the system prompt, you can see I've defined the task and the guidelines this AI agent needs to follow. We've also outlined the total word count for the script. So if you need a longer script, all you have to do is change the word count from 200 to 500 or 1,000 words, so on. But for the purpose of this video, I'm going to leave it at 200 words. Looking at the output, it's a short 200-word script, exactly as instructed. This story is then sent over to the Google Sheet in the story column, as you can see. We also pass this story to our Scene AI agent, which is responsible for breaking down the story into individual scenes, then creating image prompts for each scene and video prompts as well. This is a very robust task for the agent to handle, so we need to power it with a highly detailed prompt that outlines the rules and guidelines. As you can see here in the system prompt, I have defined the role of this agent and the rules it needs to follow, which includes splitting the story into different scenes. I've also specified the prompt generation guidelines, which are responsible for generating the video and image prompts. You can find this prompt inside our community. Once this agent has completed processing our request, it outputs a highly detailed and structured result consisting of 14 different scenes, which include voiceover text, image prompts, and video prompts. Next, we pass this output to a split node to separate each scene into 14 items, making it easier to store them in our Google Sheet. This time, we're using the production sheet. If you look closely, you'll see that I'm passing the relevant JSON string into the columns. Now, here's the important part. This setup gives us full editable control. That means we can review and edit the prompts or even adjust the scene text directly in the sheet before sending them to the image models, video model, or the voiceover generator. This way, nothing goes through unchecked. You have the flexibility to refine the outputs, make corrections, and ensure the prompts meet your standards before they're used in production. Storing these prompts in the sheet also allows us to keep track of the generated images, videos, and voiceovers. If we look at my previous runs and open one of these images, for example, you'll see that if you ever need access to these assets later, you can easily find them organized inside this Google Sheet. Now, with the prompts ready, let's execute this node, the Store Images and Voiceover Google Sheet, which will run the next collection of nodes. We'll cover these nodes once they're done. What these nodes did was create the voiceovers, generate the images, and then store them in our Google Sheet. As you can see for these 14 scenes, we now have voiceover links and image links. If we open a random one, you'll see it maintains the image style of Psyche Depth. Now, let's explore the nodes to see how those images and voiceovers were created. First, we have this Google Sheet node, which retrieves these prompts for us again. As you can see, there are 14 items in the output section. The reason we do this is so that if we make any changes to the voiceover text or image prompts, N8N can pull the updated information. Once we have those prompts, we pass them to the Create Voiceover sub workflow. If we open it up, you'll see it generated 14 MP3 files. By clicking View Sub Execution, we can look inside the sub workflow. Here, we're using an 11 Labs node, where we pass in 14 text strings along with the voice ID values. To connect 11 Labs to N8N, all you need to do is add your API key. Click Create New Credentials, head over to 11 Labs, go to Developers, select API keys, and finally click Create Key. Give your key a name, make sure you assign the correct permissions, then click Create Key. Copy your API key, return to N8N, paste it into the 11 Labs API key field, and click Save. Next, we need to upload this audio to Google Drive. If you don't know how to set up your Google Drive credentials, I have a video linked above that walks you through the process. After that, we update the file permissions so the audio files are shareable. Then we remove all the silent parts from the audio using FFmpeg, which I've self-hosted on DigitalOcean. I cover more details about installing FFmpeg on your own server inside my community. As you can see, we pass the audio URL from Google Drive into this JSON body, and in return we get 14 items, those MP3 files with the silent parts removed. We then pass them along to the final node, which outputs the result you see in the Create Voiceover sub-workflow node. If we go back to the main workflow, you'll see those 14 items listed here. Now let's move on to the create image sub-workflow. It works almost the same way as the voiceover sub-workflow. If we open this node, you'll see it outputted 14 image URLs from the sub-workflow. Clicking on the sub-execution, you'll find a similar workflow structure. We're passing these 14 image prompts to the generate images node, which uses the Flux image model, the most affordable option at just 6 cents per image. This model works perfectly for this type of content. We're running it through wavespeed.ai, which acts like a marketplace for AI models. This is the endpoint where we're sending the request, and you'll also need to include the message in the JSON body. If we expand it, you can see the exact format required by wavespeed.ai. Looking at the results, you'll notice we're passing the image prompts directly from the Google Sheet. As with any HTTP request node, you'll need to configure your credentials. I've already covered this process in a previous video and in our quick setup guide inside the community. Once this node runs, it submits 14 items, each marked as in queue. To handle this, we use another node to check whether they're complete. If they're not, the workflow loops, waits 60 seconds, and checks again. When the status changes to done, it returns all the image URLs, just like before. Finally, we use a set node to pass the image URLs back into the main workflow. Returning to the main workflow and opening the create image sub-workflow, you can now see all 14 image URLs. This brings us back to the Google Sheet node. When it runs, it links back to the sheet and updates both the image and voiceover columns. At this point, you can review the images and voiceovers to confirm everything looks correct before moving on to animate them with the video prompts. Now we've reached the final section of the workflow. This is where everything comes together. The voiceovers and images are animated into full video scenes. This brings us to the final steps, which involve taking the voiceovers and images and animating them. Let's now run this final Google Sheet node. This we'll call the final collection of nodes. Now that it's complete, let's take a look. As you can see, it updated the production status to done and also outputted the final video URL, which we can preview by clicking this link.
You think letting go is a decision. Quit the texts, delete the photos, move on. But what if I told you there's secret knowledge most people miss? Letting go isn't just a choice. It's a slow biological unraveling you cannot consciously control. Most believe grief is mental. The truth is a biological reality wired by evolution. At first, it looks harmless. You tell yourself, I'm fine, but you still check their profile at 2 a.m., or your stomach drops when a message pings. Those are subconscious signals, tiny behaviors your brain and hormones send before your mind catches up. Science shows oxytocin, dopamine, and your limbic system keep replaying attachment scripts. You can force a polite smile, but you cannot consciously control pupil dilation, voice pitch, or the way your heart races when their name appears. That's the scary part most don't realize. Then it escalates. Patterns repeat. Decisions get hijacked. You end up back where you started. Evolution didn't make us ruthless at detaching. It made us cling. Watch for concrete signs. Lingering glances at photos, reflexive scrollers, sudden quiet when someone mentions their name. Those are not choices, they're signals. If you want real freedom, start by noticing the signals before you act. Like and subscribe if you want the next video on rewiring those responses, because your future relationships are literally at stake.
And there you go. Now let's go back to N8N and see how we managed to animate those images and combine them with the voiceovers to create the full video. Here's what we did. After storing the images in the Google Sheet, we used the Get Images node to pull the updated image links from the sheet, just in case you replaced any images you didn't like. This ensures N8N always has the latest image links. As you can see, we pulled all 14 items from the sheet. Once again, we passed them to the Create Video sub-workflow. If we open this node, you'll see it returned 14 video links, one for each scene that was created earlier in the workflow. If we view the sub-execution of this workflow, you'll see it looks very similar to the previous ones. Opening the Generate Video node, you can see we're sending an HTTP request to wavespeed.ai, the same service we used for generating the images. The only difference here is that now we're using the ByteDance video model CDance V1, which costs 8 cents per video. This is by far the cheapest option and works perfectly for this style of video. If we look at the JSON body, you'll see that we're passing both the image URL and the video prompt, the same structure we received from wavespeed.ai. When this node ran, we got 14 items, which, just like before, are initially in the queue. To handle this, we need to check their status using a get video node and an if node. If the system isn't done yet, it loops back and checks again before passing the video URLs to the set node, so we can send them along to the main workflow. Again, if we open this create video node, you'll see all 14 video URLs listed here. Moving along, the next node is a Google Sheet node, which stores the videos and then retrieves them again, just like before, so we can pass them to the combine sub workflow. If we open this node, you'll see one final video URL, the one we just previewed. Now let's go into the sub-execution workflow to see how this was set up. You'll see we have two tasks, one to combine the videos together and another to add captions. In case you want captions on these videos, you have that option here. We pass these items through a code node, which builds the JSON string needed to send the data to the self-hosted FFmpeg. If we open this node, you'll see that all I passed here is a JSON string. We also need to create a status check for the video to confirm if it's done. If it isn't, the workflow loops back, waits, and checks again. Once the video is complete, it's passed to the caption task, which is also part of the self-hosted setup, covered in detail inside my community. We then check the video status again to confirm completion before looping back. Once it's finished, the video is passed back to the main workflow. If we return there, you'll see the same video output. And finally, we update the production status to done.